Aha. Hello. Right? Let me just check and see if I'm got sound. Yeah, sounds like it. It's really low quality though. Be great if it gets to higher quality. I think it'll bump up. I'm gonna go ahead and say that it will bump up, and that I am in fact streaming right now. In which case, I will say to you, hello. Wow, this is probably a really confusing view. Can I make my face big? Let's make my face nice and big. Big face. Don't look at the infinity of zooming windows. Hello, my name is John. Good to see you. Some of you might be watching this for class, others for other purposes. Whatever. Great to see you. I am going to do a brief overview today of an introduction to 3D scenes and editing scenes in Godot. Very brief. Hopefully you are already somewhat familiar, but I'll cover that briefly. Then I will show you a little bit of a bonus feature, how to start working with mouse motion, both in 2D and in 3D, and we're going to use that mouse motion to create a very simple first-person controller. Okay, that's all that's officially on the docket, but if we get done with that early, maybe I'll also show you some extra stuff about 3D, like textures and materials and all that. Okay, so it should be pretty fun. Dive on in. If you're watching this for Fordham and you're watching it on April 8th, go enjoy the eclipse. Don't watch this during the eclipse. And I'll see you in class on Thursday. But if you're not watching it for Fordham, I also hope you enjoyed the eclipse. I don't know. Cool beans. Okay, I'm going to make my face invisible. I'm going to try to make my face invisible. I'm streaming this. I'm not going to edit this because editing is a real pain in the neck. So we're just going to... we're going to do it live, and I hope you can enjoy following along. I believe everything should look good. I've done some streaming with this account before. I'm just going to triple check though. I'll see maybe like, let's see if I can see some, yeah, that looks like I can see the editor in the background. I think it should be nice and clear and crisp. Yeah, welcome to this stream. Okay, so I'm going to just show you briefly a very simple thing, a simple 3D scene. We have a character body 3D. Which has a mesh instance and a collision shape. It has a neck and a camera, which I'll get to in a little bit. We also have a very simple level with a floor and a thing so you can tell what's around. And I'll just click play and I will show you how this works. So we can look around and we can move backwards and forwards, currently just with the arrow keys, which is kind of annoying. But this is what we're going to be building towards. So I will show you how we can make that in Godot 4. If you're starting out, go ahead and create a blank new project and create a new scene. And go ahead and create a 3D scene, right? Again, there are three sort of fundamental node types in Godot. We're going to be working in 3D today, so we're going to create a 3D scene. And as you can see, right, we are in our 3D viewport, so we can navigate around pretty easily. You just hold down the right mouse button, and then you can use W, A, S, and D to move around. You can also use Q and E to go up and down. If you hold the right mouse button and look, you'll sort of like pan and rotate where you are. If you have a middle mouse button, you can also do that, I guess. There's something different. You can also hold Shift and while you're pressing keys to fly around a little bit faster. And if you have a scroll wheel, you'll see that you can sort of scroll and change the speed at which you move as well. So that's also a handy way to move around in 3D. Okay, so the first thing we're going to want to do in order to create a level that you can navigate is typically we like to have a floor. So I'm actually going to go ahead and create a, before I do that, I'm going to make a node 3D and just call it level. I like to put my, I like to organize my nodes so that things don't get too messy. So it's nice to have just a basic 3D levels node, which you can put every subsequent piece of the level inside of. So I'm going to go ahead and create the floor. I'll create a CSG box, which stands for Constructive Solid Geometry. There you go. The more you know. Anyway, I'm going to create a box 3D. And again, CSG shapes are nice because firstly, they have these little manipulator handles, which are kind of fun. And they also have built-in collision shapes, so that's nice. Again, they're not as performant as just regular meshes and collision shapes, but for what we're doing, they get the job done. So that's a decent floor. But if you want to make a really big floor, just go over to the size here and just make it like 100, right? And then you can make the Z also 100. And then that's like a pretty decent like floor size, okay? The next thing I'm going to do is just give this give this CSG box collision shapes. So I'm going to hit use collision, and that will turn on the collision shape for it. I believe you can see it turn on and off. No, you can't, but it turns it on. Just trust that it does. Okay, so now we have a box. We have a nice floor with a mesh with a collision shape on it. So if we have a character body or something, it won't fall through it. It's pretty nice. I'm going to go ahead and save this scene as main. Main. I'm going to just right click on it and set it as the main scene, and then I'm going to run the whole project, and I don't see anything, right? Because, as we have established in 3D, we always need at least a camera to see things from. Because otherwise we aren't going to know what perspective we're looking at, right? In 2D, it's a lot simpler. In 2D, you just sort of have the window and the viewport, and you can say, like, well, if something is within that view, we're going to draw it. But in 3D, because it's a whole, virtual three-dimensional space, we need to explicitly tell Gato from what perspective we want to view the scene from. So in all 3D scenes, we want to have a camera. So I'm going to go ahead and add a camera 3D. And I'll take this camera and pull it over here. I'll pull it over here. I'll tilt it down a little bit. Again, you can, when you have a camera selected, you can always see this little preview icon, and you can click it to sort of see the view from the camera, which is pretty nice. Then you can unclick it, and if you want to see them both at the same, if you want to see the view and move the camera at the same time, you can use Control-2 to split the viewport in two, and then you can have one of those viewports be a from the perspective of the camera. So then you can do things like finally adjust your camera position. And then you can hit Control-1 to make it disappear. So that's nice. So now I'm going to save that and run this scene. And right, it looks all dark and not like what we see, because we also need to give Gato in 3D scenes. We need to give explicit lighting information, okay? Because the way 3D scenes are rendered, we simulate light coming from a light source and bouncing off of surfaces and into the lens of the camera. So the easiest way to do that is to just add something called a directional light 3D to your scene. And you'll see suddenly, right, once we add it, we've actually changed the light in the viewport here. That's because typically, actually, before we have anything, if we don't have any nodes in the scene, Gato will be smart enough to give us just a default rendering environment. So that way we can just like see things with some basic lighting and world environment settings. But as soon as you start to change any of the lighting settings, it'll override that. So you can also just add this sun to the scene, the sun that we have in the world environment or in the default editor. So you can just click on these three dots up here and change the some of the properties of the light. But that's basically the same thing as just adding a directional light 3D and then fiddling with its properties, right? If we just take this light and turn it down from the sky, that's basically what we just had. And you'll notice, right, the icon for this node in the viewport is a sun. That's because directional light 3Ds are basically simulating suns or moons or other large light sources. The way it works is it is a light source that is infinitely far away. So the actual position of your light source doesn't matter, right? You can even put it underneath the objects because its actual position in space doesn't really matter. The light is being simulated from infinitely far away. However, the direction of it does matter a lot. So if you change the angle, right, now we're sort of getting a light source that's kind of coming from the side, basically. And you'll see, actually, if we have a world environment, we can actually see changing the directional light position moves the position of our little sun, okay? Which is kind of cool. But so if we put it way down over here, it's almost like a sunrise or a sunset, yeah? And the directional light 3D, like all nodes, has a whole bunch of settings that you can play around with. So you can sort of mess with the light itself, right? You can change the color of the light. You can change the energy of the light, how intense it is. You can make it negative. Wow, that's kind of nuts. I didn't know you could do that. There's all sorts of stuff you can do with it. Okay, I'm just going to leave it default since we're not really focusing on fiddling with that stuff today. But you always want to add a directional light 3D to your scene. Or you want to add some sort of light source. There's actually a bunch of different types of lights. There's, if you just search light, you'll see Omni-Light, Spotlight, Light Map, there's all these different fancy types of lights you can use. But you want to have at least one light in your scene. And that way the sun, the light source, will emit light from its position, right? The light is going to bounce off this floor and into the lens of the camera. So now when we run our scene, it looks a little bit better. It doesn't look totally right because, firstly, you can see that there's no background, right? And also the color looks slightly different. That's because the world environment also emits light. There's sort of ambient light that the world environment emits, and kind of there's like extra colors and stuff that kind of come from the sky and sort of the cloud cover and the fogs and all that. So if you really want things to look exactly like you see in the viewport, you're also going to want to add a world environment node. And so you can just click on these three dots, and you can mess with some very basic settings here if you want. I'll make a purple ground. That's nice. And then I'll add the environment to the scene. And now when I run it, it should look pretty much exactly like it, right? It's worth noting that the world environment has a boatload of other fun settings to play with, including like fog, and glow, where you can like make things sort of like very, let's see, can we turn on, you can make things like very bright and kind of like a bloom effect. You can really play with all sorts of stuff. So feel free to go nuts on that. But for the most part, this is going to be good for now. Okay. So we have a basic level. That's great. Now what we want to add is a character that can navigate this level. Okay. I'm just going to pull this up here, and now I'm going to add a character body 3D, which is very similar to a character body 2D. As a matter of fact, when we create it, we'll see we have an error. The error is exactly the same error we get when we try and create a character body 2D. We need to have a collision shape. So I'm going to add a collision shape 3D. And we see we have an error here. Same type of error we get for a collision shape 2D. We're going to need a collision shape specified. So I'm going to go ahead and go over to the Shape tab and go click on the Capsule Shape 3D. And then I'm going to hit F I'm going to click on the node that I want and hit F on the keyboard to sort of center it. And we'll see that we're sort of stuck through the floor a little bit, which is not ideal. So I'm going to grab this character body 3D and just drag it up. And now we'll see it is kind of on the floor right at the origin. It's a little hard to tell though, because we don't actually have any sort of visual instance. We just have a collision shape. So I'm also going to add what's known as a mesh instance 3D. And I'm going to go into the mesh, give the mesh a shape, and give it a capsule shape. And there we go. Now we have a character body 3D. It looks like it's still in the floor a little bit, so I'm going to click on the character node, click on this up arrow, hold control, and drag up a little bit. And that's pretty good. He's like floating a little bit, but I don't really care that much. I think it's fine. So now I'm going to save the scene and run it. And we'll see there's our character sort of sitting on the ground. It's pretty cool. Let's make it so that our character can move around, right? In order to make anything move dynamically in Godot, or in Gato, we need to have a script attached to the node that we want to control. So I'm going to right click on character body 3D, go to attach script, and just like character body 2D, character body 3D also has a really fun built-in template that we're going to start off with. I'm going to give it a new name, and I'm going to call it first person controller, and I'm going to save it. And you'll see that we have this script already right here. Let's sort of walk through this. So the first line lets the script editor know that we're talking about the character body 3D node. So that allows us to use special functions that the character body 3D node has, like move and slide, different properties like velocity. It allows us to use these specific functions that other nodes don't have, functions and properties. Then we have a constant speed and a jump velocity that gets specified. Okay, so this is how fast we're going to move, and this is how quickly we're going to jump in the air. Then we're going to go get gravity. Okay, gravity is actually a setting that you can turn on in Godot. So we can go to project settings, and you'll see that it's here in physics 3D default gravity. Let's see if we can find it. Go down to physics 3D default gravity. So this is 9.8 meters per second, which is the default gravity that we all know and love. That is gravity here on Earth. But if you want to have like a moon game, for instance, we could make our gravity a lot less. We could do like 4.1. I don't know. That's not actually moon gravity. Don't quote me on that. But if you can change the default gravity, which is kind of wacky, then you hit close. And then if we were to run this, you'll see that we can jump pretty high in the air. Whee! It's might be a little hard to see, but you can kind of see we're very, gravity's a lot weaker suddenly. I believe gravity is also just a vector 3 though, so you don't have to change gravity that way. You could, let's do a test real quick. In the ready function, let's just print out gravity. Yeah, gravity is just a number. It's not even a vector 3. It's just a floating point. So what you could do is you can make, you could just say gravity equals 0.1. You can make your number right here, and that's going to input the gravity. That's going to affect the gravity just for this character, and you'll see that we're flying off into space. But what's nice about using these default settings is that way gravity will be consistent for any any character that you create. Whereas if you just change the gravity here, that'll just be for this particular character. But we're way off on a tear about gravity, so let's go back and use default gravity. And let's keep walking through this script and kind of like trying to pick it apart and see how it works, right? So we have the physics process function, which is, it's like the process function, except it's on the physics update loop. So it's not tied to frame rate, it's just on a fixed frame rate. And what we're checking for first is the character on the floor, right? And this is on floor function, I believe, you get that for free when you use a character body 3D. So this is one of these default functions that we get because we're using this node. We're attaching our script to this node. So we have this is character body. We have this is on floor function, and this is just going to return true or false. I believe how it works is if the character has collided with something below it, it'll return true. Otherwise, it'll return false. And so if we're not on the floor, we want to fall. And so we're going to change the velocity, which is movement, which is like this, it's your direction and speed. It's the sort of the speed per frame, I believe. We're going to change that by gravity, and we're going to multiply that by delta, which basically is going to smooth it out so that it moves nice and smooth. We fall nice and smoothly depending on how fast or slow our computer is running. So basically we're going to add, right, we're going to subtract gravity from, subtract gravity from our velocity every time we're falling until we hit the floor. So if we were to just print velocity when we're falling, you can kind of see what that looks like. So I'm going to go ahead and hit play, and you'll see right here's our velocity. It starts off right at that nice tall number. It starts off at 4.5, and then it decreases by gravity until it hits the floor, and then it stops doing that. So the next thing we're going to see is, right, if our input is action just pressed UI accept, so if we press the space bar and we're on the floor, then we're going to make our velocity equal to the jump velocity, equal to 4.5. That's why it starts up at 4.5. You can kind of see it starts at right here, right around 4.5, right? If we were to make this a lot higher, like 12, and I know that we've sort of looked at this script before, but I'm really taking this apart because I want you to feel encouraged to tinker with this script, right? You don't need to just use the default character controller as it is, but by messing with it, you can really kind of create stuff that works more specifically for the game you're trying to create. So for instance, if you want to have a game where you jump really high, you can change the jump velocity. Yeah. So yeah, that's right. That's how the jump velocity works. Then we get the input direction. Okay, so the input direction is going to be a vector. We have this nice little function in the input class that creates a vector based off of a series of input actions. So left, right, up, and down. That might sound a little bit confusing, but if I print it out, you'll see what I mean. Let's just print out this input direction. Okay, so if we print out input direction, currently it's printing out 0 and 0, but if I press left, we get -1, 0. If I press right, we get 1, 0. If I press up, we get -1, 0, and if I press down, we get 1, 0. So what this function does, this input get vector, we can click on it, we can control click on it to go see it. It says it gets an input vector by specifying 4 actions for the positive x and y axes. Okay, so it's really, as it says right here, right, it's really good for getting input from a joystick or keys. So it's a great way for trying to figure out how to convert distinct button presses into movement vectors, right? So because first we get this this directional vector, which is just between 0 and or -1 and +1. Then we're going to get a direction vector, and this is maybe the most complicated line of code in this whole script, so you don't really need to worry about this, but this transform.basis is basically like the origin, wherever your character is, like the origin in local space, and we're multiplying it by a vector 3, because we're moving in 3 dimensions, right? We have our x component, so this is this input direction, so this is the x from this input direction. Then we have 0, because you know, this is for y, which is up and down, and when we're using our forwards, backwards, left, and right, we're not changing our y velocity at all, so we're just going to keep it 0. And then finally, we are changing our z velocity, but we get the y component from the input direction vector because that's a 2-component vector. Blah! That's a lot. That's a whole lot. Don't worry about it. Then we just normalize it, and we're going to use that to change our velocity. So what that looks like is if we print this out, it'll look pretty similar to what we already have. You'll see though that we have you can. What's nice about this particular part is, right, if we're holding, firstly it's 3 vectors, or it's 3 digits. The vectors has 3 components. So you'll see that the 0 value in the middle here is the y value. But if we hold up, if I were to hold left and up at the same time, you'll see that it's nicely mathing out kind of what basically what direction we want to be moving in, right? We want to be moving a little bit to the left and a little bit to the top, versus fully, you know, up and fully down. So then, after we sort of calculate this direction, what this script does is it says if there is a direction, right? So if the direction is greater than 0, then we're going to set the velocity of x to our direction x times our speed, and then we're going to do our velocity z equals our direction z times our speed. So if there is a direction, we're going to set it. We're going to set our velocity to that direction times the speed. If there isn't, we're going to start to move towards 0. Okay, that's what this move towards function does. Move towards is another function that we get, I believe. This might just be a built-in. Yeah, this is just a built-in function, so you can actually use this with any node. You can use move towards, and it moves from from the from value to the to value by this amount. So what this means is it allows you to kind of like nicely slide from the speed that you're moving at to the 0 value at a certain rate. If you didn't have that, right, if we just said equals 0, I believe it would look kind of janky. It would look very sort of, you know, maybe stuttery is my guess. Let's see. So I'll move quickly. It looks fine. I can't even really tell the difference. If I zoomed in a little bit. Boink. Sorry, I make sound effects sometimes. Okay, let's see. I don't know. I can't really tell. I mean, yeah, you can kind of see it sort of, particularly if you're going fast, maybe. Yeah. Looks a little janky. Let's say that it looks a little janky. Anyway, all of this is a huge tangent. Let's actually go now and try and turn this script into a first-person script, right? Because if we stopped here, this is pretty good, right? You could totally turn this in if you're doing the Lab 4 assignment where you just need to have a CSG level with a character and a controller. You could absolutely turn this in. But if you're interested in trying to build out something like a first-person controller, I'm going to walk through that process now, okay? And it's worth noting that first-person controllers are really standard in the game design world, right? Everybody makes them. They're all over the place. And so if you were looking for tips and tricks on how to make a first-person controller, it's really easy to find. Firstly, you can just go to the internet. You can go to my face. Please don't. You can go to... I'm just not sure if this is still capturing. Apologies if we're in the wrong spot. You probably already saw that. But okay, you can just go to YouTube and search for, you know, Godot 4 first-person controller. It's really worth noting that with Godot in particular, there have been a lot of changes between version 4 and version 3. Syntax is very different these days, right? So I'm actually, apologies, I'm just going to take this and search on YouTube directly. Boink, boink, boink. This guy Lucky's pretty good. He's got a nice, thorough tutorial, but there's a whole bunch of them, right? There's lots and lots and lots of different first-person controller tutorials. And so you can, you know, the way that you do them, you know, there's a lot of things that are in common, right? The output is all pretty standardized, but there are several different approaches towards making a first-person controller. So if you don't like this approach, you can find many other different approaches on how to do it. So go nuts. But again, just look for stuff that is either Godot 4.x, right, specified, or is kind of within the last year, at least as of the time of recording, right? You want something kind of made within 2023, 2024. Even this one, actually, the one that I'm following is from a year ago, and it's from 4.0, and things have even changed since then. So that even though this Bramwell video is really, really good, there's some slight distinctions with syntax and stuff. So just bear that in mind when you're going to watch tutorials. And bear that in mind if you're watching this in the future. The syntax for how to do this might have changed substantially. Although I think they are trying to do that less these days. Anyway, so we have this default character controller, which is pretty nice. The first thing we want to do is, right, we have this sort of third-person bird's-eye view that's not attached at all to the character. Let's go ahead and drag this camera onto the character. And I'm going to go ahead and split the view again, and bring this camera from the perspective of it. And I'm going to move the camera down, and this is the easiest thing. I'm just going to reset the camera's position entirely. So now we have it kind of nicely inside of the person, although it's a little low. It's kind of like a belly button cam. Let's change that by dragging it up a little bit. Okay, let's save and run this. Now we have a very basic first-person camera, although notably, right, we can't move our mouse at all. And what we would really like to be able to do is use our mouse to look around up, down, left, and right. So that's what we're going to do now. So first things first, I'm going to go on a brief tangent about the mouse button, about mouse motion in general, okay? So I'm just going to create a 2D scene with our robot. Whoa. No, sorry. I'm going to create a new 2D scene with our robot. And I'm going to attach a script to it. I'll call it mouse demo. And I'm going to get rid of all this stuff, and I'm going to use the built-in function input event. And so again, this is our function that we use for listening to input events. So for instance, if I were to just print out the event, and I were to run this scene, I'm going to call this mouse demo. If I were to run the scene, you'll see, right, even as I start moving the mouse, we just get this input event mouse motion. We also have our key press events here, all sorts of, any sort of, interactions you do with the computer are captured by this input event code, okay? And so the easiest way to get the mouse motion is to listen explicitly for this, is to listen for this input event mouse motion. So what you can do is you can create a line that says if event is input event, and then you can type the letter M, and you can see all the M flavored input events. We have, well, and actually even if we just have input event, right, we have all these different input events we can choose from, including touchscreen gestures, MIDI controls. But the ones that we're interested are, we're interested in mouse stuff, right? We're interested in either mouse events, mouse button events, mouse motion events. I'm going to go ahead and grab the mouse motion. So I'll say if the event is a mouse motion event. Now let's print out the event. Now we can see a little bit more specifically what that looks like. Nope, that's the main scene because we're on a tangent. So now when I move it, right, we can see we have all these components of this event. We have a button mask, we have position. So this is the global position of the mouse. So one of the easiest things you could do is you could just say, since we're doing this attached to our icon, we could just say position equals event dot position. And that's just going to grab the position from the event. And look, now we have a thing that follows around our cursor. That's kind of cute. It's sort of a little, there's some hang-ups with it because if I were to go over here, you'll see that it sort of pops around, right? So another way we can work with mouse motion is we can use what's known as the relative position. The relative position is the amount the mouse has moved since the last time we checked. So for instance, if I were to print out event dot relative and run the correct scene, you'll see that now we have a number that specifically correlates to how quickly and how much the mouse is moving. And that's kind of a nice way to work with position. So you could do something like, say, position plus equals event dot relative. And now you'll see that it moves it around based off of the just the motion itself, which I guess has all other different sorts of issues. So there's all sorts of different things you can do with kind of mouse motion. We're going to use this relative motion in a minute for our character rotation. But the final thing I'll show you is how to use mouse presses, because some of you might be making like a 2D game. For instance, if you want to make a very simple click and drag thing, you could do, you can make a variable called drag equals false, and then you can say if input, or if event is input event mouse button, then you can make drag. You can flip the value of drag, so if it's false, you can make it true, and if it's true, you can make it false. And you can do that by saying dragged equals not dragged. Exclamation point is shorthand for saying not in code, so you can invert values. And then what you can do is you can say if dragged, then we'll make the position equal to the event dot position. And now, when you run the right scene, my God, if you're just moving the mouse, nothing happens. But if you click, you can drag, and I believe, yeah, because it's a mouse event, it both registers the up and down clicking, like the pressing and the releasing. So it actually works kind of well for a click and drag. Problem is, this isn't actually that helpful for clicking and dragging because there's nothing telling whether or not you're actually clicking on the icon itself. So if you were to have multiple of these sprites, they would all register this event, right? Like for instance, like if I had two of these guys and I had them in separate places, you'll see that I just click and drag and they both follow the same thing. So if you really wanted to figure out how to do that, you would need to, you'd probably need to detect its, like the mouse actually appearing on it, which you could do with a UI node pretty easily, but that's not the point of this video. I'm on another tangent, so I'm gonna pause there, and if you're interested, talk to me and we'll figure out how to do that. But in the meantime, let's go back to our 3D nodes and use some of this mouse stuff to figure out how to make our camera rotate. Okay, so the first thing we wanna do is, let's just make the, I don't know, let's try this. First, well, I'm gonna look at my pre-prepared version real quick and just see how I like it. Yeah, we're gonna do something that looks a little bit like this. Don't worry about this stuff yet, I'll get to that in a minute, but we're gonna say if the event is input mouse motion, then we're gonna rotate. Okay, and when you see here we have this neck. I'll explain why we want to have a neck. But first I'll just show you the simple version. Okay, so what we're gonna do is back here in our main scene, we have our character body. So we're gonna go ahead and create a new function. I'm gonna hide this. We're gonna create a function called input, our input function, event, okay? And we're gonna create this very simple mouse motion. So we're gonna say if event is, let's say mouse, input event mouse motion, input event mouse motion. If it's mouse motion, let's try doing something silly. Why don't we just try rotating the whole character by the relative X motion, right? Because what we want to do is we want to translate moving left and right to turning left and right. We want to translate looking up and down, moving up and down to looking up and down. Okay, so let's go ahead and say, let's go ahead and rotate the camera. So I'll grab the camera by dragging with control and dropping. You can also just type out on ready var camera 3D $ camera 3D. And I'll say camera.3D. So if there's mouse motion, we're going to say the camera 3D dot rotate. I'll say rotate Y. This is a function that rotates this node along the Y degree by an angle. And the angle we'll just say is event dot position, or event dot relative dot x. Okay, this is gonna look pretty crazy, but let's see what happens. So we started off, and is anything happening? Hard to tell. Let's see if we have any input events. A couple things that could be happening. Print event. No, we don't have any input events. So I did something wrong. I think I needed to have an underscore here. That probably is it. Yeah, okay. So now we're spinning around like crazy, right? Why are we spinning around like crazy? For starters, rotate y, this function, is looking for an angle in radians. Now, radians are annoying. Radians are from trigonometry. If you remember trigonometry, let's find a picture of radians. You might remember from trig that radians are like, they're basically in pi units. So like, you know, we have this, let's see, if this is 0, we start at 0 and we get, and if we wanted to get to 360 degrees, you kind of want to remember that radians are basically, oh my god, I don't know why it's going this way. Okay, so radians are basically in measurements of pi. So pi takes you to about 180 degrees, and 2 pi gets you all the way around the circle, okay? And radians are just sort of like they're kind of a standard in game dev. You do sort of have to learn sort of to work with them. There's lots of very easy ways to convert degrees into radians, but for starters, like this relative motion that we're using right here, right, this event.relative x, we're giving that to a function that's expecting a radian. So that's actually going to be a lot, right? Because in radians, like 2 or 6.2 is 360 degrees. When we say, you know, rotate by this number, which is event, let's see, relative dot x, you'll see that this number is typically in the neighborhood of like, you know, can go up to like, looked like, I mean, you know, 120. So that's a really, really big number. So we're whipping around really fast. And so that's why you can kind of see that it looks like we're completely tweaking out, because we're just rotating around very, very quickly. So the easiest thing to do is just make this number smaller. You can make numbers smaller by multiplying them by a decimal point. So you can do 0.001. And we'll run it now. And now you'll see that's a little bit better. But there's a couple things wrong. Firstly, what's annoying is that when I move my mouse to the right, you'll see it's a little hard to tell. I'm going to add an object to this scene so you can kind of see more specifically what I'm talking about. I'll add a CSG cylinder, and I'll put it over here. This is just going to be for visual reference. Okay, so now when I didn't put it anywhere within the view of the camera. So let's move it here and then here. Okay, so now, right, if I move to the left, I rotate to the right, and if I move to the right, I rotate to the left. So that's not really what we want, okay? So that's kind of the opposite of what we want, right? And typically when we need to get the opposite of what we want in code, that's a matter of making something negative. It's a matter of making something negative. So I'm just going to make this a negative number, right? I'm going to make this I'm going to get the inverse of the relative motion. And now you'll see when I move to the left, I look to the left. And this is starting to feel pretty good. However, what's sort of annoying is, firstly, we see the mouse button, right? We see this mouse cursor. And when I get to the edge of the screen, I shouldn't have made it big. When I get to the edge of the screen, the mouse goes off and we stop paying attention, right? The game stops listening. That's not really how 3D games work, right? Typically, you don't actually have a mouse cursor. The mouse is invisible, and you can just move as much as you want. So in order to do that, we have to do something. We have to do what's known as sort of input capturing. Okay, so what we're going to do is we're going to make it so that when we click, we start capturing the input, and that's going to make the mouse disappear. But we're also going to want to get our mouse back so that we can use our computer and not have our mouse captured by this game all the time. So what I'll do is I'll make a new if statement. I'll say if event dot let's say if event is input event mouse button. So if I click, I'm going to make the input dot mouse mode, the mouse mode of the input system, equal to input mouse mode captured. Okay, and this is going to make the cursor disappear, and it's going to allow us to. It's going to give us basically the result we want. But let's also now make something to undo that so that we can actually get our mouse back and continue to work with our computer. So I'm going to make another line, and I'll say else if I'll say input dot is action just pressed UI cancel. So UI cancel by default is the escape button. I'll say input dot mouse mode equals input mouse mode visible. And this is our regular mouse mode where we can see the cursor. I think this is going to work. Let's try it and see. So we have our mouse. I click, and you notice that the cursor disappears. What's also nice about that is I can keep going. So I can just move my mouse all the way to the right, all the way to the left, and it's just going to keep rotating the camera around, but it's never going to hit any sort of boundary. Now I'm going to hit escape, and I get my mouse back, and then I can close the window. That's great. So that works pretty good. So now let's try and figure out a couple other things. Okay, so for starters, we've done left and right in a pretty decent way, but we haven't done up and down. And what's weird about up and down is, actually, I don't think we can need a neck. I'm going to do this without a neck. You can create a neck and you can rotate the camera on the neck, but I think if let's just try rotating the camera. So let's just go ahead and do camera.rotate. Let's just copy and paste this, but I'm going to rotate on the. I'm kind of confused. Let's take a look. Let's go to the camera. Right, we want to rotate along this guy. We want to look up and down, right? Oh, I know why we want a neck. Yeah, there's a good, we should have a neck. We're going to make a neck. I'm going to add a node called node 3D. I'm going to call it neck. I'm going to put the camera inside of the neck. And then I'm going to go back to the character body. I'm going to change this so that it's correct now, right, because we changed the path. Then I'm going to also reference the neck. And what we're going to do is we're going to, when we're rotating up and down, we're going to rotate the neck. But when we rotate left and right, we're just going to rotate the camera. So the camera is fine, but now we just need to say down here, instead of camera 3D rotate, we're going to say neck rotate. And instead of rotate Y, we're going to rotate X. And instead of the X component, right, instead of left and right, we want up and down. So we're going to say event.relative Y. And let's see what that looks like. I could have done it wrong. Actually, no, that's okay. It's a little creepy. Oh yeah, it's a little, I feel we're kind of drunk. So I've done something wrong. Let me go back to my template and see. Neck.rotate Y. Camera.rotate X. let's just take this. Let's just copy and paste. Copying and pasting is great. Back here in the main. Let me just make sure I'm doing this right. It looks like I think I got it backwards. So we want the neck to rotate left and right. My apologies. And then we want the camera. We want the neck to rotate up and down. And then we want the camera to rotate right and left. Yeah, that's probably fine. Let's see. Ooh, God. Nope. That feels terrible. It feels really bad. What am I doing wrong? Neck, rotate Y, event relative dot X, camera 3D, rotate X, event relative dot Y. I might have just had the X and Y backwards. Let's see if this works. Okay, this works good. I'm not going to mess with it too much. You can kind of see, yeah, you can see how this works. However, you'll also see a couple of things wrong with this. Firstly, you can look all the way upside down. That's not really how video games work, right? We don't like to sort of look up and down forever, okay? So in order to do that, we need to clamp this value, okay? We don't want to keep rotating beyond a certain threshold. So in order to clamp a value in Godot, we can use a built-in function called clamp. Clamp is really nice. So in order to use this, what we're going to do is we're going to get the, we're going to say neck dot rotate rotation dot y equals clamp. And then with clamp, we have the value that we're clamping, and then we have a minimum and a maximum. And what it does is it whatever this value is, it keeps it within these bounds. So if you have 0 and 100, and you give it like 105, it'll just keep it stuck at 100. Or if you give it -10, it'll keep it stuck at 0. So we're going to take the current value that it is, and we're going to clamp it. So we're going to say the value is going to be the neck rotation dot y, neck dot rotation dot y, and we're going to clamp it to. Unfortunately, right, we're currently in radians. However, what we can do is we can just use this other built-in function called degree deg to rad, which just will convert degrees into radians because, you know, lots of game developers don't want to think in radians. So I'm going to say, right, necks typically just go down to like, I mean, I guess you could do 0 to 90, but that's a little extreme. So why don't we say like, what did I say over here? What did I say in my template? -30 to 60. I guess 0 is probably the horizon, right? So I guess it would be -90, +90. So I'll do this. I'll do -30 and 60. So I'm going to have -30 as my lower bounds and +60 as my upper bounds. Now if I save it and run it, you'll see that I can look up. Okay, come on. Somebody's pranking me. What's happening? Why is that like that? Let's try it one more time. Nope, that's not correct. What did we do wrong? Did something wrong. Oh my gosh, I'm getting so confused. It's the X. It's the X component of the rotation because. Why? Why is it the X component? No, yep, it is the X component. It's right. This is something to really wrap your head around, right? Even though you're thinking about looking up and down, we're rotating around the x-axis. This up and down motion is rotation around the x-axis. So what we want to say actually is instead of rotation.y, we want to say we're not talking about the neck, right? The neck is what looks left and right. The camera 3D is what looks up and down. And we're going to say camera 3D.rotation.x equals camera 3D dot rotation dot x. All right, now when we click it, we can look up and down, and that's great. However, there's two other things that we need to do, right? For starters, we can only move with the arrow keys, and that's not very conducive to using your mouse. And what's also sort of tricky is you'll notice that, if you're looking straight, it all works fine, but as soon as you rotate a little bit, if I press up, you'll see it's a little hard to tell, I guess, but what you'll see is that basically the motion that you move in is still fixed to the original orientation you're in, right? We're not actually changing. We want to go forwards and backwards based off of the relative angle that we're pointing at, right? But currently, in order to go towards this cylinder, I need to press, if I'm pressing up right now and I'm walking backwards. So it's all totally out of whack, right? That's because we're using the original origin point as our basis for calculating our direction, and what we actually want to use is we want to check based off of the rotation that we've already done. Okay, so that's a little complicated, but there's two things that we're trying to do right now, right? Basically, we want to remap the controls so that we can use WASD, and we want to fix this rotation. So first thing I'm going to do is go to Project Settings. I'm going to go to Input Map, and I'm going to add WASD as my movement options. So I'll add up, down, left, and right. And then I will assign keys to them. I'll assign W to up, S to down, A to left, and D to right. Then I'm going to go back to this physics process function, and instead of UI left, I'm just going to delete this, right? Because we created these custom actions called left, right, up, and down. And that's pretty good. Now I'm going to hit play, and I'll show you how that works, right? So now we can move up, down, left, and right. So that works good, but we still have the problem. If I rotate, we're still not moving in the correct direction. That's because, again, we're using this basis. We're using the basis of the character body itself. We're using its basis as the sort of the foundation for the direction. And what we want to use actually is we want to use the transform basis of the neck. Okay, so all you need to do is just add in neck dot transform basis. And then we can hit play. And now you'll see that if I look around, it moves all in the directions. It's all moving relative to the transform of the neck, which is what we want. So this is pretty cool. This is a good foundational template for first-person movement and stuff. I'm running a little tight on time, so I think I am going to wrap it up here. I guess I'll just give you a quick preview of how to kind of start fiddling around with some very basic texture settings. So if you want, we'll cover this more in class, but know that... Yeah, let's talk about it this way, right? So we have these objects, right? We have these meshes, these CSG meshes, and these character meshes, and just regular meshes. Those are geometry. Those are like shapes. But then each geometry also has what's known as a material property. And currently the material property is empty. But if you click on either a CSG node or a mesh, right? Click on it and then go to material, and then create a new standard material. You'll see, for starters, the color changes a little bit, and you'll see we have this little sphere over here. And we can click on this sphere, and you'll see all of these options open up. Okay, we have transparency, shading, vertex color, albedo. Let's check out albedo. Albedo is basically a fancy word for what color is the object. You'll see here's white. You can click on white. You can change the color of the object. Okay. You'll also see that there's a texture. So this is how you do things like if you want to create ground, you can add in a dirt texture here. And I'm going to do a much more in-depth look at all of this stuff. But know that when we do things in 3D, when we create 3D scenes, all 3D objects have geometry data, which is their shape, and they also have material data, which is all the information about what color they are, how do they absorb light, how do they bounce light off of them, what's their roughness, their texture, how shiny are they. They have all this extra detailed information that you can access with the material settings, okay? So every 3D object has a material option, right? Here's our mesh. I'm gonna go click on it, and I'll give it a material, and it's got all these things. I'll change the albedo, which is the color, right? And now we have like a blue player, okay? So there's a lot in here to really sort of play around with. I'm not going to go into it in depth, but just start poking around in there, and we'll talk about it soon. Okay, so that's going to cover it for today. I hope this was helpful and fun. Enjoy the eclipse, and I will see you all in the future. Bye.